Shut up and sit down.
Well, hey everybody, welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to the video. So today's episode, we're going to look at 3 questions that are very common in installation practices that you might run into as a electrician in the field. But they're also very common for exam preparation, and being able to dissect the question and understanding how to answer it is a key part of practicing or getting prepared to take an exam. But let's not forget that a lot of your career is going to be spent with the hands-on. And when you're doing the hands-on, you got to remember not to neglect the mental part of the game, and that is learning the National Electrical Code, because this document right here, this is a safety standard. It is not an installation manual. It's not designed to tell you how you should do something as far as an installation. However, it does give a lot of prescriptive practices in here that talk about certain installations in order to meet a minimum safety standard. Okay. Now, a lot of people hate the term minimum safety, but it is. If you meet that NEC, that is the minimally as safe as you're going to get when it comes to electrical installations, safeguarding persons and property from the hazards that arise from working with electricity. You can go above and beyond the NEC. You're free to do that. But the NEC is a minimum standard that you must meet as a baseline. Learning the NEC is critical to the success in your career. Whether you're a lead guy, the foreman, you're the master, the owner, or you're an apprentice that's learning the trade, you really are going to make things much easier for you if you learn the NEC. Now, lucky for you, we have created a program called the Fast Tracks program that is, without a doubt, the best online learning program out there, from the reading material, which really works on things that really people struggle with, and that is reading comprehension, great illustrations, competency reviews, quizzes, practice exams, everything. And you also get access to me personally on Wednesday nights where we do our live stream using Zoom. Okay, it's not open to the public. It's open to Fast Tracks members. And so it is really a way that you can really hone those skills as a really well-rounded electrician. So hopefully you'll think about checking out our programs. But today's episode, we are going to be examining 3 questions in how to examine the root and what you might look for in order to be able to answer these questions. Okay, so let's kind of jump into that and work on these questions. All right, so this is episode 3 in the Ask Paul series. So we've got a collection of questions that have been presented, and we will work through these. All right, the first question that we have says the total rating of utilization equipment fastened in place other than luminaires shall not exceed blank percent of the branch circuit amperage rating where lighting units, cord and plug connected utilization equipment that are not fastened in place, or both of those, are also supplied. So you have utilization equipment that is fastened in place, means the equipment is fastened down, but it's on a branch circuit that is also supplying potential lighting units or also supplying other types of utilization equipment that is not fastened in place. Right? So if that condition exists, and I could supply the lighting units or the cord and plug connected utilization equipment that's not fastened in place on that branch circuit that is supplying utilization equipment that is fastened in place, or I could have both the lighting and utilization equipment that's not fastened in place sharing that circuit with the utilization equipment that is fastened in place. But you have to do something that is going to basically limit the amp rating of that utilization equipment that's fastened in place from being on that branch circuit. If it's a 20 amp branch circuit, it's a 20 amp branch circuit. But this rule is if you're going to have the lighting units and cord and plug connected utilization equipment that is not fastened in place on the same branch circuit as various utilization equipments that is fastened in place, then you're going to have to take a strong look at the utilization equipment that is fastened in place. Because if you look at the nameplate, you're going to limit the rating of that utilization equipment from being applied to that branch circuit. So we'll look at that, but we have to look at the code. Now, in order to dissect this question, you have to really understand what we're looking for. We're basically looking for the limitations on the amp rating of the utilization equipment that's fastened in place because it's on the same branch circuit as these other things. So we're talking about a branch circuit. So obviously, if we're going to use the index, we're going to look under branch circuits. And really here, we're talking about amps is another way of talking about load. It could be expressed in VA. It could be expressed in kW. But ultimately, once we solve it all down, it also could be expressed in amps, okay, which is current. And so when we think of all these things, what we're trying to see is, okay, I've got a rating of this utilization equipment, and I want to put it on this branch circuit, but this branch circuit has these other things on it, then I'm going to probably have to think really hard about the piece of equipment, the utilization equipment, and what its maximum rating is, and can it be on this circuit? But we're talking about a branch circuit. So I would look. Now, the other thing is this really tells me that we're looking about what is the permissible load that I can actually place on this branch circuit if all these other conditions apply. And that's what we're hunting for. So one of the things that I like to tell students to do is really dissect here. Look up the definition of utilization equipment so that you know that that applies to most appliances. And again, this isn't just a residential, okay? This rule here that we're looking at could also apply to non-residential or commercial applications, all right? This is a branch circuit rule that's going to limit the size or the amp output or amp rating of utilization equipment that's fastened in place if it's on sharing circuits, if it's sharing the branch circuit with these other things, okay? So we want to look up the definition of utilization equipment so that we fully understand it. It's probably going to encompass most of the appliances that we have. But we also need to understand that branch circuits are perfectly allowed to have things like lighting and cord and plug connected utilization equipment that is not fastened in place on it. Right? Be very careful. Now, of course, the code does have certain things that require individual branch circuits that can only supply certain pieces of equipment, and you're going to look at the listing of the product itself in order to be able to determine that, or their instruction manuals. But in general, we're just talking about the general branch circuit applications. Also remember that if you're dealing with things like small appliance branch circuits that are required in 210.11c, then be careful because that has specific rules that says what you can and what you can't put on those small appliance branch circuits and things like that. So don't remember we have all those other rules that we have to be aware of. But let's answer this question. If you go to the index, you'll probably see branch circuits, and under branch circuits, you'll see something that talks about permissible loads, because that's what we're saying here. We're trying to find out if I've got all these conditions that are in place on this branch circuit, and I want to put a utilization equipment on it that is fastened in place, but it's part of a circuit that has lighting units and other utilization equipment that is not fastened in place, that is cord and plug connected, what's the maximum size, if you will, of this utilization equipment that is fastened in place can I apply to this branch circuit? That's what we're hunting for. Okay, so again, branch circuit is where you want to go in the index. Now, I teach people in our Fast Tracks program that take your time in a question like this, really dissect it, look up utilization equipment, look up branch circuit, right? Look up all these things so that you get a better understanding, because look, if you're going to take an exam and you got to spend all your time in the index, you're going to run out of time. You're not going to finish that exam. Okay, you can't look up everything. There's a certain amount of knowledge that you have to have accumulated during your studies, like in our Fast Tracks program, or in the field. Hopefully you have a robust program that you're learning the NEC that you can apply also to the skills that are hands-on, because hands-on aren't the only thing. I know plenty of really good electricians that are really bad with code, and they end up having to do things multiple times because they don't know the code. They could be so much better as an electrician if they would learn both sides, the physical part and the mental part. And that's what the code's all about. It's the mental part that you have to learn. All right, so we're dissecting this, and you go back and you look it up under branch circuit, and what you're going to find is that the answer is going to be in 210.23a2. Okay, so what we've got to do is we're going to need to go to the NEC. So let's go on and do that right now. And we're in the NEC, and you see I'm down here now, and we will actually go down to 210. I'm in the electronic version. Again, 2020 NEC. And we'll go into 210.23A2. All right, so if you had looked under branch circuit in the index, you would see that we're talking about permissible loads. Again, that's the whole concept. What are the loads that we're talking about that we can actually put on this branch circuit when we have those other conditions that are in place, right? So here's what it says. And in our case, we're talking about 15 and 20 amp branch circuits. But again, also understand that there's rules for 30 amp, 40 and 50 amp as well that you have to be aware of, right? So in this case right here, what is the question is, what is the maximum? Okay, for utilization equipment fastened in place, and we're looking for a percentage, right? So here is the utilization equipment fastened in place, and that's what we were looking at in the question. Remember, the question wants to know what is the total rating of this utilization equipment that's fastened in place? What is the total rating that's permitted on that branch circuit if the branch circuit also has what? Other utilization equipment that isn't fastened in place, cord and plug connected, or that same branch circuit that's supplying that fastened in place utilization equipment, but also happens to be supplying lighting units that are on that same branch circuit. Then I'm going to have to limit the size of that utilization equipment that is fastened in place on that branch circuit, okay? And it's a lot you have to think about, because you might end up saying, well, I can't do it now. So I might have to run an individual branch circuit just to this utilization equipment that's fastened in place, because it would originally been shared with a branch circuit that has these other things, but now I can't put the load that I need on this branch circuit because of those limitations. So let's look at it right here. It says the total rating, okay, this is a rating of the utilization equipment that is fastened in place, again, other than luminaires, shall not exceed 50% of the branch circuit ampere rating where lighting units, cord and plug connected utilization equipment not fastened in place, or both of those are also supplied, okay? So we're talking about a branch circuit that's supplying a lot of loads here, okay? 50%. So that's basically saying if I have a 20 amp branch circuit, that's what the rating is. That's what the rating is of the overcurrent device. It's a 20 amp branch circuit. In our case, since it's 15 or 20 amp, so it's going to be a 20 amp branch circuit that's protecting a 12 gauge, say. And so I cannot exceed 50% of that branch circuit rating with the rating of my utilization equipment, okay? So if my utilization equipment is rated 10 amps, and I'm doing this on a 15 amp branch circuit, and that branch circuit also supplies other cord and plug connected utilization equipment that's not fastened in place, or it's the same branch circuit that supplies lighting outlets as well, or both of those, then I am limited to the size of the utilization equipment that is fastened in place on that branch circuit. Okay, it's still a 20 amp branch circuit. However, as you see here, I would limit the total rating of the utilization equipment that is fastened in place can't exceed 50%. So that piece of utilization equipment on a 15 amp circuit could not exceed 7.5 amps. So I look at the piece of equipment, the utilization equipment, I look at its rating. If that rating is not more than 7.5 amps, then it's okay to be on that circuit. If it's greater than 7.5 amps, if it's a 15 amp branch circuit, then it can't be on that circuit. So I would need to run an individual branch circuit for that utilization equipment that's fastened in place. Or I would simply remove the ability to have lighting or the cord and plug connected utilization equipment that is not fastened in place, which essentially would turn that into an individual branch circuit for that utilization equipment that is fastened in place. See, these are all the things that you have to think about. But this is not changing the rating of the branch circuit. This is altering the utilization equipment and its rating that can be applied to that branch circuit because of all these other conditions that are in play, okay? So the answer to this question is 50%, and it's based on 210.23A2. Isn't that a lot of information to be aware of? I think that that's what I think that makes this trade so amazing, because there's so many little things, and the NEC is a wonderful document, and people argue about it all the time, but I tell you, it is laid out really well, and it's not because I serve on code making panels, okay? If I stop serving on code making panels tomorrow, I still have a fondness for this document because of the way it's laid out. I am not a big fan of UL documents. I'm not a big fan of ICC documents. I am a big fan of the NEC because of the way it's laid out, and I think that over 100 years, it's really served its purpose as a safety standard, and I just think that people should get more involved in it. Every electrician should really focus on learning the NEC. Okay, let's get back to the PowerPoint presentation. And so we answered this question, and it's obviously 50%, okay? All right, the next question that we're going to deal with is, if the vertical rise is greater than blank feet, 250 kcml copper conductors in vertical raceways shall be supported. All right, what are we talking about here? This is a raceway. We're not talking about cables. We're talking about a raceway. So it could be intermediate, rigid, any conduit, okay, any tubing. Those are all raceways, okay? A cable is not a raceway. So even though MC cable, the conductors will slip if you run them vertically, that's not what we're talking about here. Now, I'll give you a little tip in a minute about running MC cable of the larger size. I'll give you a little tip. But right now, let's focus on the question. So if I was in the real world and I'm going into my code book, I'm going to look under raceways, and I'm going to look for terms like vertical raceways, okay? Vertical is a key trigger for me, but I'm also going to think about supported, okay? This terminology here, oops, sorry about that. This terminology right here for supported in raceways. So I'm going to look for those things. And again, it's not at this stage about time. Now, eventually you'll be able to answer this question really quickly. In fact, you might even know exactly where to go if you've been in our Fast Tracks program, because we talk about this. And that's the whole purpose of a program like we offer, because it takes you systematically through every article and every section of significant importance, so that you start to build on that knowledge, that repository of knowledge that you can call on in a moment's notice. And that's really important when you're doing an exam, because many people know that for over 20 years, I've been talking about the wave method of preparing for an exam. And that is, go through the first wave on an exam, answer the questions that you know right away. Any question that you can answer in less than a minute, you answer it. Those that you can't after a minute, you mark it and you go to the next question. You don't dwell on it. You go to the next question. You answer the first wave, as many as you can answer that you just know. The ones that you marked that you did not know, that's your next wave. You go through those, you spend a little more time. You can spend up to 2 minutes per question on those. If you still can't answer it after 2 minutes, you leave it marked. If you can't answer it, you unmark it and you go to the next question. You move through that wave, also skipping all calculations and saving them for the third wave. When you get to the third wave, you'll still have those questions with check marks on it that you have not answered. You need to make sure you answer those. So you basically will spend another 2 minutes on that question. If you can't answer it in 2 minutes, you go to the next one. When you finish the third wave, you want to make sure that at the end of the day, even if you couldn't answer that question in 2 minutes, you take the most logical guess you can before you move on. Now, still leave it marked, because after the third wave, you can come back to those questions again and essentially create a fourth wave. But the point being is, by the time you get done the third wave, I don't want any unanswered questions. Okay. Now, if you're in an exam that does calculations separate than code lookup questions, then you follow the same principle, but at least on the exam portion that does nothing but calculations, they usually give you more than enough time to be able to spend the adequate amount of time you need to answer those calculation questions. It's just the ones where you have the lookup that tend to give people a problem. So if you follow that wave method, you're going to have a lot of success, I promise you. All right, so let's get back to this question. So I've dissected it. And I'm looking in the back, and I'm looking under things like vertical. I'm looking under raceways. Under raceways, I'm looking for key triggers like support or vertical support. All those type of things. Take your time. Really dissect the question. Why do we do this? When you're studying for exam, it's not so much about the time. A lot of people will tell you that. They're full of it. It's about using the technique of using the index and learning what is not covered in the index. I have been very successful training students for over 30 years using this method to gain knowledge. And that is, take a question, dissect the key roots, look for the answers in the index, because what happens is you start to learn what is and what is not in the index. And it really starts to have recall when you're on an exam. But it's not just for exams. Even in the field, It allows you to look at a situation and try to identify what you really are asking. What am I asking? Because a lot of times you'll have a long, detailed question, but they're asking something very specific. And if you get used to identifying a specific question, like right here, I'm trying to find out those inner conductors and how I have to support them in a raceway. Because when I run conductors inside of a raceway vertically, that's a lot of weight. Every foot of a 250 kc mill can be a pound or more. Okay, now you put a set of, let's say, A, B, C, a neutral, and an equipment ground in a raceway vertically, that's a lot of weight. That could be as much as 4 and 5 pounds per foot. That is all being drawn down by gravity. And so those conductors are just waiting to slip. Okay, so what about the terminals? At the bottom of this installation, you've got terminals that are handling all that weight. They're not designed for that. So this rule allows me to support those conductors inside of a raceway. Okay, so when we're looking at this, we want to look at the index, dissect everything. Ultimately, what's going to happen is it's going to take you to table 300.19a, and that is the internal support of conductors within raceways. Now, don't get that confused now with a cable assembly, MC, that's run vertically. We'll talk about that. I'll give you a little tip at the end of this question. But we're talking about internal support of conductors, okay? They are going to be pulling down on this installation. All right, so let's go to the NEC. And let's see what we've got to do. So we've got to, oops, sorry about that. We got to go to the top. And we got to go to 300, which is the general requirements for wiring methods. And we're going to go 300.19. And also remember that if you get a lot of questions that are talking about general wiring applications, things like that, it's going to be in 300. That's the general catch-all area. Then it starts getting specific to the wiring methods and things like that in chapter 3. Okay, but the general requirements, like for example, depth of cover for raceways underground, that's under 300.5. I mean, that's in the general requirements. So as you start to learn, it makes it easier for where you need to go. But it just takes time. And that's what we developed our Fast Tracks program to do. Okay, so let's go to 300.19. And here's what we're looking at right here. 300.19, supporting conductors in a vertical raceway. Spacing intervals, maximum. Okay, so this is the maximum spacing intervals where we're going to have to add support based on a conductor's size. It says conductors in vertical raceways shall be supported if the vertical rise exceeds the value in table 319A. Okay, so once it exceeds the value in this table, then we're going to have to do some actual supporting vertically for these conductors. It says at least one support method shall be provided for each conductor at the top of the vertical raceway or as close to the top as practical. Now, this can be done by wedges that are placed into the top, and the conductors go into these little openings in the wedges. That's one way to do it. There's other ways to do it in a run. You could actually put a junction box and you have individual supports that mount inside of an enclosure that actually grab onto the conductors to help support that weight. Or sometimes there are little nodules that you actually route the conductors around it, and it adds that friction that's actually going to help support those conductors over the span of a vertical run. There's many ways to do this. Reach out to your manufacturers and let them know what you need. You'd be surprised what they have available for you. Now it says, intermediate supports shall be provided as necessary to limit supported conductor lengths to not greater than those values specified in table 319A. Okay, so in this case, we had a 250 kc mill, correct? So that's going to be down here. So it's over 4/0 through 350. So that's the area we want to be. And the support of conductors in vertical runs is not greater than, in this case, it was copper, so that is 60 feet. Now notice the difference between 60 feet for copper and 135 feet for aluminum. Obviously, that's a direct weight relationship. Okay, aluminum is obviously lighter than copper, so a lot of people are opting to use aluminum for a vertical run application. It is lighter. It does tend to be a little bigger conductor, but today most of the aluminum that we use is called compact aluminum. So it doesn't have all those little voids between the strands. It basically looks like a solid conductor. because it has trapezoid strands that interlock. And to be honest with you, it replicates a solid conductor. Now, as far as ampacity goes, aluminum's obviously got to be bigger than copper to carry the same relative amount of current. But now that it's all compact, most of us in the industry make only compact conductors for aluminum. What you're going to find is the size difference is not so big anymore. Okay, so it can be a benefit. Okay, so you got copper options, aluminum, but the biggest difference is I'd have to support every 60 feet. And in this case, I only have to do it every 135 feet. Now, if this run with 250 is less than 60 feet, then I'm not triggering this requirement. Okay, but if it is 60 feet and I have longer runs, then I have the requirement to actually have this in the intermediate portion of the run at any portion that is greater than 60 feet based on that size, then I have to add some type of support. Okay, so anyway, making sure you fully understand it, it says conductors in vertical runs shall be supported if the vertical rise exceeds the values in table 300.19a. So that's the first trigger. I have a 60-foot run of 250 kc mil, then I need a support. Put a wedge at the top. There you go. If it's over 60 feet, let's say it's 120 feet, then what am I going to need? I'm going to need not only support at the top, but I'm also going to need the support at an intermediate level, okay, so that my supports are every 60 feet if I'm dealing with 250 kc mil, okay? All right, so anyway, that's how that rule applies. Now, remember I told you something about MC cable? You'll see an exception here that says steel wire armored cable. That is not MC cable, okay? This rule doesn't apply to MC cable, but I'm going to tell you what. Now, Google steel wire armored cable. Might look very similar, but that has a steel wire supporting system, and the connectors that connect to the boxes are designed to connect onto that steel wire and to support that assembly. Okay, not the same as an MC cable. Now, we all know that large MC cable in a vertical application, those conductors can slip. So I always recommend that you follow the same spacing requirement for MC cable by simply putting offsets at the same intervals. If it was a 250 kc mil MC cable, then I would follow the same rule. At about 60 feet, I would put an offset in it if I can. And that will add that necessary friction to those conductors and help reduce the actual slippage in those large MC cables. Now, of course, the industry also makes MC cables that the conductors inside of it don't slip. Okay, many cases are called vertical run, those things like that, or riser. And it's not because it's riser rated. It's riser because that's what we call that run, vertical run. It's sometimes called risers. So that's the situation. Don't think that it's riser rated in a sense that there's some type of fire rating on that. Okay, it's not. It's just riser based on the installation. We could also call that a vertical run cable as well, and it would all be the same. So that's kind of a tip when you're dealing with large types of MC cable, right? The conductors will slip. The other real concern here with these slipping conductors and raceways and cables is because the terminals itself are going to bear all that weight. And we need something to remove the weight that's going to be on those terminals because we don't want to stress them out and they eventually could break down. Okay, so we're also thinking of that. Also, if something were to fail, then all of that wire could just come flowing out into an equipment room. And again, if somebody's in there, it can be a tragic incident if that were to actually take place. Okay. All right, so enough of that one. I think we've answered the question. 60 feet is our answer. Let's kind of go back to the presentation. So if the riser is greater than 60 feet, 250 kc mil conductors in vertical raceways shall be supported. So the answer is 60 feet, right? Straightforward. Again, this is all based on the size of the conductor, okay? All right, the next question we have is dealing with operating rooms. So obviously in a healthcare facility. So each operating room in a healthcare facility shall be provided with a minimum of blank receptacles. How many receptacles do I need for this operating room? Okay. This is obviously a healthcare facility, but if I'm dissecting this and I'm using the index, because remember, that's what we want to do. We want to get familiar with the index. Then we would look up things that are very specific to this question. Like obviously we're talking about an operating room. It's very specific. Also, we're talking about receptacles. So if we're looking under operating room and see if there's something there, or maybe we look under healthcare facilities and we're looking for the reference to operating room, or maybe under healthcare facilities, we're looking for the reference to receptacles. You might get a bunch of different code sections to look at, but they're all going to be in 517. Don't have any problem with writing those down, because there might be 3 or 4 that you can look at. If you don't see the answer in the one that you need right away, just jump to the next one. While you're in the index, another tip for people during an exam is make sure that you go to the index, go there once, write what you need down, and then go looking for the answer in the different sections that it's given you in the index, okay? Spend the time you need there. When you're studying for an exam, spend the time you need to be in the index, because, again, it's about learning what's not there and what is there, and it's just a matter of repetition. When you get down to your last week, then you can work on speed, okay? But by then, you're going to use these tips to get much better. All right, so in this one here, the trigger for me is operating room. I'm obviously going to look under healthcare facility while I'm there. But again, the whole thing is, what is the number of receptacles? Right? Now, here's the good news about an exam. Your exam is going to give you A, B, C, or D. And you can always use the answers as additional triggers. So when I'm going looking, I'm physically looking for answers that are in A, B, C, and D to stick out. Okay? That's what I'm doing during the question. Now, when I train you in our Fast Tracks program, I do not give you A, B, C, and Ds, because we train you, the reading material and the images, illustrations, and the competency reviews are focusing on you retaining the information. I don't teach tips and tricks. I teach you how to learn the NEC. I try to target reading comprehension. That's a key thing that I target in helping you read something. Then I put an illustration to it. Then I test you with competency. And then you come to Wednesday night sessions and you ask me questions and I elaborate. That's how you learn the NEC. And that's how I try to teach you. Okay. So in this case, operating room, healthcare facility, and receptacles are all key triggers for me. Take the time to look that up. But in our case, we're going to obviously be in 517 because that is healthcare facilities. And we're in 19C1. And you're going to get that from the index if you look under operating rooms. And also you might find it under healthcare facility. Again, it's all about the number of receptacles. All right, so let's go over to the NEC and look under 517.19C1 and see what it is that we have to do. Oops, I'm sorry about that. I keep opening the wrong thing on my end. So let's go to the top. And I'm going to go to 517. And if you're in the Fast Tracks program, you learn, again, where healthcare facilities are. We have a lot of what's called flashcards. And you can obviously make an unlimited number of flashcards yourself. They will really teach you to learn all the articles, all the sections, all the key tables. You can make any number of flashcards you want. And I always recommend the first thing that students do is go in there and start making flashcards for every article in the code so that you can look at it and start to be able to just nail it. 430 motors, okay, things like that. Right? Just boom, boom, boom. 517 healthcare facility applications, 210 branch circuits, 215 feeder applications, 220 load calculations for branch, feeder, and service. You just will get used to just seeing it. And if you see that in a question, that's half the battle. All right, so in this case right here, we're going to go to 517.19. And it was C1. So here's the operating rooms, but you'll notice that we have receptacle requirements, bed location, branch circuit requirements, the patient bed location receptacle requirements, the number that's required there. Again, this is all about receptacles. So here we've got operating room receptacles. Again, key trigger, key term, we're talking about an operating room. The receptacles are what are the requirements for how many do we need? So here's a minimum number right here. All right, so C1, it says each operating room shall be provided with a minimum of 36 receptacles divided between at least 2 branch circuits, okay? So again, so 36 of them, I have to split them amongst 2 branch circuits, and now it's going to tell me which branch circuits I can use. But we've already answered our question. Now here's the great thing about an exam. They're going to probably have in there 14 receptacles, 36 receptacles, 15 receptacles. They're going to have a number there. This is a key trigger for me because as I'm looking at the question, I'm using the answers to target what I'm looking for and help narrow it down. In the real world, you're just trying to search for the answer. And you're in a healthcare facility, and your boss comes to you, or you're the boss, and you go, "Hey, man, we got to have how many receptacles in an operating room?" And you're going to know that, all right, I got to have 36 receptacles. He's going to say, "God, that's a lot of duplex receptacles," and you're going to say, "Oh, no. One duplex is 2 receptacles." Okay, it didn't say I have to have 36 duplex receptacles. 36, boss. That's, again, a duplex counts as 2. All right. You learn all these things. And it says, oh, by the way, at least 12 receptacles, but no more than 24 shall be connected to either of the following. Okay. So a normal system branch circuit required by 517.19a, or I can supply the 12 and no more than 24 can be on a branch circuit, the critical branch circuit supplied by a different transfer switch than the other receptacles at that same location. So those other receptacles may be on the normal system. And then, of course, you might have the critical branch that's there. So again, these are the rules that you have to follow. But at the end of the day, your question was, how many receptacles are required there? And the answer is 36, right? So that answers that question for you. And so let's just go back to the presentation. And I always tell people, don't overthink the question. This is all it's asking. In that operating room, what's the minimum number of receptacles I have to have? 36. That's the answer, right? So again, there's so many ways to dissect it, but that's what we kind of teach in our program. All right, now, if you have any questions about the National Electrical Code and you really want more information on our Fast Tracks program, it is truly, in my opinion, and I am biased, but based on what we put into it, the extra grading that we do, again, you can buy books and DVDs, but nobody's there to quantify your answers and give you feedback. That's what I do. That's my whole goal here, is to teach you to understand the NEC. And if you get something wrong, I need to explain it to you so that you can understand it. I need you to go look up when I give you some feedback, and you look it up in the code and you have that aha moment. You go, I get it now. I understand, because I need you to learn it. I need you to absorb it. It doesn't do me any good if I just give you the answers. So I make you work for it. And that's what this program is all about. And again, it's not just for exam prep. It's for learning the NEC in general. I have companies that have their whole staff in our programs. We have residential, commercial, industrial, grounding and bonding, Electricity 101. And again, our most famous course is our Fast Tracks program. If you want more information on really, truly learning the NEC and a better understanding of it, to really get deep into all of the things that the NEC has to offer and really become skilled at this document, check out our program. Go to masterthenec.com and you'll see in our list, the Fast Tracks program under the course list. Go check it out. There's a demo there that you can watch that I will run you through the course, let you see all the features, kind of show you how it's laid out. You'll see the pricing there. You'll see how long you have to access the program there. Everything for you is there. And if you really want to take your game to the next level, we'd love to see you as part of our program. All right. Till next time, folks, stay safe. God bless. And remember, it's not just about the hands-on. It's also about the mental game. Learning the NEC is so important to really fundamentally take your game to the next level. Okay. Till next time, stay safe. God bless.
Shut up and sit down.